Hello, everyone. Welcome to this lesson, which is Population Dynamics 1. We're going to be looking at the various different factors that affect population dynamics and what population dynamics actually are. So the first bit we've got to talk about then is what are population dynamics? Well, these are the factors that control population increase and decrease. Quite often we describe these as being in dynamic equilibrium. Which is a moving balance, a location where when one thing increases, another thing will either increase or decrease in response, bringing it to a new balance, basically. And we're going to come across lots of dynamic equilibriums as we go through environmental science. The first factor we're going to look at is our birth rate. So the birth rate is the maximum birth rate of a species. This is also called the nativity rate. And it's determined by the natural ability of the species to reproduce. So species that have a lot of predation, for example, will in response have lots of births per year. So make up for the fact that lots of their young ones are getting eaten quickly. So in relation then to birth rate, we have our death rate. And this is the number of individuals per period of time which are dying off. It's also called the mortality rate. So you can see how that's related to the one above. And this could be due to things like predation, disease, food availability, those sort of factors will affect the death rate. So what we have in ecology is a theory that describes how different species have evolved to cope with these two different pressures. Because obviously, if a species has a much greater death rate than it does birth rate, then it will soon go extinct. So in response to that, you have these two different species sort of. Let's just move that down a bit better this time. So I get it all. There we go. These two species, R-selected and K-selected species, are different approaches to dealing with birth and death rates. So R-selected species are species that respond rapidly needed L in there, to changing conditions. And they do this by having high birth rates and typically, but not always, low parental involvement. So parents can produce lots of offspring really quickly, and then the offspring are left to their own devices. They reach maturity quickly. So that the offspring can go on to breed themselves if they survive. And typically, they will be able to disperse widely. So they will be able to spread out quickly as well. And some examples of this are things like the old green fly that you get on roses. That's not a very good picture of a green fly, but hopefully otherwise known as aphids. You have things like dandelions. So hopefully everyone's familiar with the old dandelion clock with the seeds that are going out in all different directions. You blow on it to tell the time. You have things like rabbits. They will breed quickly, the young will mature quickly to have offspring of their own as well. Okay, fluffy tail. There we go. So, the alternative to this are things like K-selected species. So, K-selected species take a long time to respond to any population declines because they are typically found in more stable conditions. So they will invest heavily in their young and have few young. They will typically live a long time as well to make up for that low birth rates that they are or have. Okay, this means that if there's been a sudden change in environment, they don't really cope very well with it. They don't have the ability to replace losses quickly. So some examples of K-selected species are things like whales. There we go. So whales are a good example of this. So they will only have one calf every sort of couple of years, and they will keep the calf with them for a long time. Whales are a good example as well because they suffered heavily at the hands of human hunters, which resulted in a really quick population decline. Elephants as well, they are a good example for the same reason. They have few young that they invest heavily in. They live a long time. And they have suffered heavily at the hands of hunters as well, which has resulted in really rapid population declines in a lot of different parts of Africa, for example, and their Asian range as well. So now that we've looked at birth rate, death rate, and the two theories of how they can respond, how animals evolve to respond to this, we're going to look at forecasting population changes. So if we want to forecast a population change, we have our starting population. I'm just going to abbreviate population to POP. And then we add on our births for that year or period of time. And we add on any immigration. So this is animals moving into the area. And then we take away deaths. And we also take away emigrants. Which are individuals that have moved away from our area of interest. And this will tell us if the population is either increasing over time or decreasing over time. And this is important because it will allow us to establish or help to establish if we have reached something which is called maximum sustainable yield, which is the amount of individuals that can be extracted from a population before it sees an unsustainable long-term population decline. Okay, so this is a really important idea within environmental science, managing things like fish stocks or a forest or some other natural resource.